MCTV Motion Control Television Channel. Training Class Segment. Motion Control Technology Lecture 2. The 5 Steps of Motion Control: Planning, Command, Execution, Feedback, and Compensation. Step 1. Planning. Motion control planning must first be based on the actual application to determine the requirements for absolute accuracy or repeatability accuracy, speed, and acceleration for each coordinate dimension, and then appropriately and reasonably configure the entire motion control system software and hardware. Next, it involves motion trajectory planning, planning of motor movement trends, steady state and dynamic error and error compensation planning, foresight planning, screw and gap compensation tables, speed and acceleration feed-forward, soft landing, etc. Step 2. The controller commands. The controller to transmit motion trajectory control and axis control commands by sending signals in the following formats: pulse, analog signals, PWM, encoder following, acceleration curves, electronic gears, electronic cams, linear and arc interpolation, spline interpolation, synchronization, gantry locking, position capture, high-speed I/O, homing, etc. The controller sends axis control and trajectory control commands through various communication protocols: PCI bus, 104 bus, EtherCAT, Ethernet, PowerLink, Profibus, CAN-Open, CAN, RS-485, etc. Step 3. Execute. Motor and driver are the power and source of executing commands, the core technology in motion control, and the key technology for challenging the limits of motion control, achieving precise and rapid execution of commands through precise transmission, precise mechanical motion conversion, and high-speed feedback. Types of control motors include stepper motors, multipolar servo motors, AC servo motors, DC brush servo motors, DC brushless servo motors, torque motors, linear motors, voice coil motors, ceramic motors, spindle motors, AC induction motors, etc. Types of motor drivers are classified by the type of motor driven: stepper motor drivers, multipolar servo motor drivers, AC servo drivers, DC brush servo drivers, DC brushless servo drivers, ceramic motor drivers, spindle motor drivers, inverters, linear amplifiers, two-phase current mode drivers. They are also categorized by the format of commands: pulse digital drivers, analog drivers, PWM amplifiers, two-phase current mode drivers, CAN-Open drivers, EtherCAT drivers, RS-485 drivers, etc. Step 4. Feedback. The physical quantities of motion control feedback mainly include angle, displacement, force and torque, speed, and acceleration. Additionally, external factors such as mechanical deformation, transmission clearance, friction and damping, temperature, vibration, vacuum level, and radiation will also affect precise control, so it is necessary to measure and feedback these physical quantity changes for motion control compensation. Motor feedback sensors include quadrature incremental encoders, single-ended incremental encoders, and DAT 2-point to absolute encoders, hyperphase absolute encoders, SSI absolute encoders, BISI absolute encoders, rotary transformers, tachometers, potentiometers, force and torque sensors, etc. 0.5 S external environment perception sensors include temperature sensors, pressure sensors, vacuum sensors, gyroscopic testers, tilt testers, vibration measuring instruments, laser distance meters, visual systems, vacuum measuring instruments, etc. Step 5. Compensation. 0.5 S deformation compensation. Screw rod compensation table. Linearity compensation is a means of accuracy control. Temperature compensation. Accuracy is affected by temperature changes compensation table. Force and torque compensation. Fluctuations in force and torque greatly impact sensitive surface contact processing, requiring the introduction of force and torque compensation. Backlash compensation, applicable to transmission links such as reducers and screws. Dual-end feedback backlash. Encoders are installed at both the input and output ends of the transmission chain to perform backlash compensation. Attitude compensation, gyroscopic testers, tilt angle compensation,